All right, Unit 9, Day 1. Going to review some laws of exponents and then talk about new stuff with exponents, rational exponents. So, laws of exponents, talked about in Algebra 1. And I've got your 6 properties, your 6 laws right here. So remember, just a quick review of these, right? When you multiply the same base, right, the important stuff out of here, multiplying the same base, you add the exponents, right? When you are dividing the same base, you subtract your exponents. Anything to the 0 power is 1, except 0. That's undefined, but we'll get into that later. And then if you have a power raised to another power, you multiply the exponents. And if you have a product or a quotient raised to a power, so if you got stuff in parentheses being raised to a power, then everything in those parentheses needs to be raised to that power, okay? And then negative exponents, that doesn't make the base negative, it just changes the position of the base within a fraction. So like in this first one right here, a to the negative n, right? That's in the numerator of a fraction. So to make that exponent positive, we take this thing and we shift it to the denominator to make it 1 over a to the positive n. And then likewise, if it's 1 over a to the negative n, to make that exponent positive, we shift it up to that numerator and it becomes a to the positive n. So negative exponent just tells you to move it in the fraction, okay, to make it positive. So laws of exponents here, simplifying. First thing here, we've got 5 squared times 5 to the 6th. So to simplify this, the bases are both 5, so they're the same. They're being multiplied, so that means we need to add our exponents. So 5 to the 2 plus 6 is 5 to the 8th, which is a big old number, okay? 7y to the 5th times 6y. So in this case, remember, this is all being multiplied together. So we have 7 times 6 times y to the 5th times y to the 1st. So 7 times 6 is 42. Y to the 5th times y to the 1st. Same bases being multiplied, so we add, and we get 42y to the 6th. Okay? Number 3, same thing. All this stuff's being multiplied together. So we're going to go negative 3 times 5 times x squared times x to the 1st, times y to the 7th times y to the 6th. So negative 3 times 5 is negative 15. And then we're going to add those exponents because everything's being multiplied together. So negative 15x to the 3rd, y to the, that's 7 plus 6 is 13. Okay? So we got those. Now, number 4, y to the 6th divided by y. So we have the same bases being divided this time. So remember that denominator, that y in the denominator is y to the 1st power. So when we divide the same base, we subtract exponents. So y to the 6th minus 1 would be y to the 5th. Okay? More division here. 6 to the 13th divided by 6 squared. Again, both of these are the same base. They're base 6. So that just means we're going to take 6, and then we're dividing, so we're going to subtract those exponents. 6 to the 11th. Okay? We got that. Now, 6, 10a to the 7th, b to the 9th, divided by 15a to the 5th, b to the 4th. So with these coefficients out front, we're going to divide those, right? And then we have a to the 7th, a to the 5th. So we're going to go a to the 7 minus 5, right? Because those a's are being divided. And then same thing here. The b's are being divided. So we're going to subtract those exponents. And then with this 10 over 15, we can divide a 5 out of both of those and make it 2/3. And then that would be a squared b to the 5th. Right? You can leave it like that, or if you were to multiply all this out, you could just make it a, 2a squared b to the 5th all over 3. Okay, both of those are acceptable answers, all right? Number 7, we have 3x squared to the 0 power. So everything in there is being raised to the 0 power, and anything to the 0 power is 1. So that whole thing is just 1. Okay? Same thing with 8. Negative 3x plus 7 to the 0 power. So all of that is being raised to the 0. So this is just 1. Now, when we get into number 9, 8x to the 0 plus 5. So in this case, the only thing being raised to the 0 power is the x. So x to the 0 is 1. So 8 times 1 is 8 plus 5 is 13. So you got to be careful about what's actually being raised to the 0 power, all right? Number 10, 2 to the negative 3rd. So we got a negative exponent. So right now, remember with negative exponents, we need to think about fractions in terms of fractions. So 2 to the negative 3rd, to make that exponent positive, we need to take this thing and shift it to the denominator. So that would become positive 2 to the 3rd in the bottom. And since we took all the stuff out of the top, we need a placeholder. So we put a 1 up there. And then this would just be 2 to the 3rd is 8. So 1 over 8. Okay? Number 11, 4x to the negative 4. So again, we got to be careful about what's actually being raised to the negative 4th power. So this is really 4 to the 1st times x to the negative 4. So the only thing being raised to the negative 4th power is the x. So that's the only thing that's going to be moved. So that 4 is going to stay in the numerator, and then it would turn to x to the positive 4th in the denominator. Okay? And then same thing with 12. Be careful about what's actually being raised to that negative exponent. So in this case, right, we're going to take this x to the negative 2nd, and to make it positive, we're going to shift it down to the bottom. And this y to the negative 3rd in the bottom, to make it positive, we're going to shift it to the top. So we'd have 3 on top, and then y to the 3rd, and then 5 on bottom, x squared. That's what we got, okay? And then for 13, we have x squared to the 8th power. So we have a power to a power. So that means we're going to multiply those powers. So x to the 2 times 8 would be x to the 16th. Okay? Y to the negative 3rd to the 4th. So again, power to a power. So we're going to take negative 3 times 4 and get negative 12. And we're not done simplifying until all of our exponents are positive. So again, think about it's in a numerator. So to make that positive, we shift it to the denominator, and then there's nothing left in the numerator, so we have that 1 as a placeholder, right? And then for 15, we have 4x cubed yz all to the 3rd power. So we have a bunch of stuff in parentheses being cubed. So to simplify that, we take everything in those parentheses and we cube it. So everything in there gets taken to the 3rd power. Okay? So then we simplify. 4 to the 3rd is 64 times x cubed cubed. So power to a power, we multiply those. So 3 times 3. And then 1 times 3. And then 1 times 3. So we have 64. That would be x to the 9th, y to the 3rd, z to the 3rd. Right? And then same thing goes with fractions. If you have a fraction raised to a power, just like this, everything in this set of parentheses needs to be, in this case, squared. Right? So all of this stuff in here needs to be squared. So 2 squared is 4. A to the 5th squared, right? Power to a power. So multiply. And then b to the 7th squared in the denominator, so we multiply. So 4a to the 10th over b to the 14th is what we end up with that. All right. So again, these are all laws of exponents you talk about in Algebra 1. But the new stuff for today is rational exponents. And remember, rational numbers are fractions. So when we have an exponent that's a fraction, we can actually change that into radicals, right? So biggest thing here is if we have the nth root of x, that can turn into x to the 1 over n, right? We can convert back and forth between rational exponents and radicals. And then now if we generalize that into be anything, any fraction, right? So the nth root of x to the m, we can turn into x to the m over n. So if we actually throw in some numbers like this, if we have the cube root of x squared, then this index goes to the denominator and the power goes to the numerator. So in this case, what you want to think about is it's x to the, and then the numerator is the exponent of the radicand, and then the denominator is the index. And remember, with this stuff, right, this is the index, and then the stuff underneath the radical is called the radicand, right? We talked about that before. So now if we simplify this stuff, to simplify 64 to the 2/3, so remember this means it's the power over the index. So we're going to convert this to a radical. So we have 64, and then the index is going to be 3, and the power of this thing is going to be squared. So we take the cube root of 64. Again, you can use your calculator for that. Cube root of 64 is 4. Squared is 16. Okay, so 64 to the 2/3 is 16. Same thing here. 4 to the 5/2. Here's our power and our index. So we've got that index is 2, so square root, and then power is 5. So the square root of 4 is 2 to the 5th. Again, use your calculator, but that's 32, right? Now 19, 8 to the 5th to the 1/3. All the same rules apply to rational exponents. So this is a power to a power. So we're going to take 5 times 1/3. So that would be 8 to the 5/3. So now same deal. Power, index, right? So the cube root of 8 to the 5th power. Cube root of 8 is 2. And then 2 to the 5th power, again, is 32. Right? Now for 20. 25 to the 1/2 plus 36 to the 1/2, all being squared. So what we have to do is this addition sign kind of throws stuff off. So we have to work with each thing individually. So remember, in these, it's power over index. So this would be 25, and then be square root to the 1st, right? And then same thing, 36 to the 1/2. Index 2, power 1. All that's being squared, okay? So we simplify everything we can inside first order of operations. So square root of 25 is 5 to the 1st. Plus square root of 36 is 6 to the 1st. Right? 5 to the 1st and 6 to the 1st are just 5 and 6. And then add those to get 11. And 11 squared is 121. Okay? 21 here, 4 to the 3.5. So we need to change this into a rational exponent, so a fraction. So we need to take 3.5 and turn it into a fraction. Okay, so remember, this first decimal place right here is called the 10th. So this is 3 5/10, which we could simplify to be 3 1/2. And then we're going to convert this into a improper fraction. So to do that, we multiply and add. So 2 times 3 is 6 plus 1 is 7 over 2. So this is the same thing as saying 4 to the 7 over 2. Okay, so power index. So the square root of 4 to the 7th. Square root of 4 is 2. To the 7th is 128. Okay? And then last one here, 32 to the negative 3/5. So we're going to do the same thing here. But before we change it to a radical, we've got to address this negative exponent. So remember, to change the sign of an exponent, we've got to take this thing and shift it to the denominator. So that would become positive 3/5 when it's in the denominator. And we took all that out of the numerator, so there's just a 1 up there. Now we just work with the bottom, right? So 1 over, again, power index, right? So the 5th root of 32 to the 3rd, okay? So 5th root, going to use your calculator. The 5th root of 32 is 2. To the 3rd power would be 8. So 1 over 8 is what we get there, all right? So exponents, rational exponents, all that stuff, okay? Make sure to try out your homework, practice this stuff, and let us know if you have any questions.